So I am Benny Michielsen. For those who do not know me, I'm a software developer or something else which is mentioned on my slide. I like technology. I like to develop applications, and from time to time it's good for everybody to look at other technologies out there to broaden your view, so you have another tool in your tool belt that you can use at on your next project. Last year I looked into machine learning, which I presented at Cloud Brewer session, at the bootcamp, I'm sorry. Somewhere before the summer vacation, I dived into HDInsight and Storm in particular, and I'm going to present to you what I've learned so far using that technology. Has anyone used HDInsight and Storm in particular? Excellent. By the end of the evening, you'll be ready to go and create your first application. So my talk is divided in three different parts. We're going to briefly look at the why Storm was created and big data in general, how you can create your own application, and then a couple of scenarios which can trigger you on how you can apply Storm in in different scenarios. That's the name. So let's first look at a little introduction. What is big data? And that's a question for you. And don't be the typical Belgian audience. Since I know a couple, Preben, what do you, and I say big data, what do you think? Indeed, big data, and one of the definitions is, yeah, it's a lot of data. Gigabytes, terabytes, petabytes of data sitting there, and they have value. And for our customers, for the business we develop applications for, they want to know what's in it. We need to gain insight in that data, hence the name. But it's not only big data, as in the size, it can also be the velocity at which the data comes into our system. Perhaps we're monitoring a couple of URLs, but people are clicking on those URLs at a very high rate, and we need to process that as well. That's also big data. Big data also means that you can cluster or use a lot of different data sources to address questions which the business or your customers are asking. Perhaps you need to grab the log of the websites you're running and grab the product database and the customer CRM information and combine those to create reports which say perhaps when are those products bought the most. Is it in the morning, is it in the evening? How long are they in their shopping cart? And you can enrich that data with the CRM data to match that with your customers and create another view on the data which the customer or the business you want to create applications for needs. So when you Google big data and Azure, you automatically end up with HDInsight. And HDInsight is Hadoop. Hadoop running on Azure. Who has never heard of Hadoop? Nobody has ever heard of, okay. No, not a problem. Hadoop is an entire ecosystem of technologies where there is a lot of different technology under the stack Hadoop. But typically when you hear Hadoop, you should automatically think MapReduce, which means we have gigabytes of data sitting somewhere. We then write some code, and that code is actually sent to the data, processed in different parts. So you create one solution, which is then split into several smaller parts, and each part does some computation, and then in the end it's all aggregated and you get the final result. Typically, you have to wait for the result, so the computation takes some time to run. And after Hadoop has run, did its job and created a report or something, you can store that and then turn off the cluster as well. And perhaps the next day you can spin up the cluster again, do some computation of the data which we accumulated over the past day, and create another report. So my time. Quick is something which you can use on Hadoop to create those jobs. Hive is another one. Hive has a Hive query language. And they all use Hadoop as the data store. HBase is something completely different, yet it's under the Hadoop umbrella. HBase is a NoSQL database and it's modeled after Google's Big Table, where you still have tables and rows, but you can have the data in those rows is grouped by column families, and which is an entirely different point of view, which compared to your normal SQL database. Then there's Spark, which is available as well, which is a in-memory parallel computing framework. And then there's Storm, and Storm will be the main topic of my talk. All of those technologies, you can all use them. If you just say HDInsight, all of them are included. It's one name for all of them together on the Azure platform. So the Storm sales pitch, I just went to their website and took some notes. It's real-time Hadoop, they say. I don't find that a very good comparison with Hadoop. Normally, you define your MapReduce functions, you fire them off, and then you wait, and you wait, and you wait, and then finally you get a result. It has, of course, it has its values, but with real-time Hadoop, Storm is actually targeted at individual data points. You want, as soon as the data is coming into our system, we want to analyze it. We want to have immediate feedback, we want to do immediate computation, not wait for a job to complete and lose any opportunity. It integrates with any queuing or database system, more on that later. There isn't any data loss. Any data which is sent to the topology, which we will create later on, will be processed. You can create transactional topologies, which means that all the data which is sent to the cluster will be processed. It's scalable, it's parallel by its nature, so you can run a lot of tasks simultaneously, and it's fault tolerant. So if any of the pieces of your cluster goes down, it will automatically restart and fire up a new task. So with that in mind, let's just dive into Storm. Let's first learn some lingo. It all starts at the beginning, a spout. A spout is a source of data. And if you read the documentation, they say it's an unbounded string. So it just keeps on pouring data into the system. This can be like a Twitter feed, which we will use later. It can mean web clicks online. It can be a queue, a message queue or something where messages are parked in Event Hub. Just keep on pushing data inside an application. The other part of a Storm application is a bolt. A bolt is a piece of computation. Perhaps it's transforming the data, perhaps it's calculating something. It's all called a bolt. And those two are connected, meaning that my spout will be the source of information and it will be sending that information to the other component, a bolt. And a bolt can also output information to other bolts. Perhaps it did a computation and it sends the result of that computation to the other bolt, which will do another job. But it's not only in a linear fashion, it can split out. Perhaps one bolt will be outputting averages and the other, well, it's also outputting the raw data. So the stream can be split into two and can even split further or merge back. It all depends on the application and the problem you want to solve. There doesn't have to be a single point which produces data. You can combine multiple spouts in your application and all feed them inside your topology. And there can even be system events, like I want to do something every 5 minutes or every minute or whatever, that can also trigger a bolt to do something. All of this combined is called a topology, and that's your Storm application. And these are these Storm topologies which you will deploy inside your HDInsight Storm cluster, and it will run and produce values. With that, let's just dive deep in and do what I said in my presentation at the beginning. Let's do some programming. Who doesn't have Twitter? Well, let's increase. Who has a Twitter account? Who doesn't have a client installed on his smartphone? You guys should install a client. The other ones can just follow along. So I've already prepared, I already did file a new project and I installed a couple of NuGet packages. If you install the HDInsight SDK, you will have some more options inside your Visual Studio. You can create Hive applications quick, and then there are a bunch of Storm templates. I started this one with the Storm application, then I deleted some classes which I don't need because I want to guide you through the system. So let's start at the beginning, and we need a source of information. So I'm going to create a spout. So let's add a new class. And I'll call this the Twitter spout. And perhaps I should talk a little bit about the goal of our application. We've just landed our next big project. We want to create an application which can monitor hashtags. We want to create a hashtag battle application where you can define multiple hashtags, and then the Twitter feed will be monitored, and whenever there's a tweet with that certain hashtag, we'll increment the count and output that to an application which is running in Azure as well. So I created a class. So far so good. Then I add a SCP namespace. The SCP namespace is automated in the DLL is automatically added when you create a Storm application using a template, or you can use NuGet to download it as well. It's actually a .NET library which enables you to create .NET applications for Storm. If you Google anything about Storm or try to find any books on the matter, you'll always find Java books, because all of it is written in Java. But thankfully, with the SDK, we can use .NET as well to create applications. So we have to implement an interface. I'll make it a little bit bigger. ISCP spout. And it has a couple of methods, ack, fail, and next tuple. Ack and fail, I won't go into detail about those, but those are necessary when you want to create the transactional topology. So when processing somewhere fails, they call fail, and then the entire batch is, or the entire tuple is rewind, and it can be sent to the system again. So now we just care about the next tuple. We also need a constructor. And the constructor will accept a context class. This context class represents all the runtime information for our application. And we'll need that to emit tuples. Have I mentioned already what a tuple is, by the way? I don't think I have. A tuple is a piece of information which is being processed by your application. It can be anything. Anything which comes inside your application is a tuple. So I have the context defined. Spouts and bolts are kind of loosely typed, as in you need to define what goes in and what goes out of my piece of code. In this case, this is a spout, so it won't have any input except for the Twitter feed, which I will connect to my spout, but it will have output. So I need to create a dictionary with these generic arguments, output schema. And we'll add one entry. We need to give it a name, and I'm just going to select the default string as name. And I need to define what is the data that my tuple will produce. Or I need to say what are the types of data which I will output. In this case, I will be outputting the hashtag, so it's a string, and the ID of a Twitter. A tweet indeed. So that will be 2 strings. So here needs 2 braces. Yes, indeed. It's late. very late. I wish we did VB.net. So I defined what my spout will be outputting, mainly 2 strings. And then I need to tell the context, well, what will be the component schema. Then there's a class I need to add, a component stream schema. I won't have any input, so that'll be null. But my output is the output schema which I defined. That's all the wiring I actually had to do for to use this spout inside my application. Now I also want to use Twitter, of course. So I added a library for that. I want to create a filtered stream. And then I can add tracks, and let's say we'll be monitoring Azure BE, and say the first session had a name, and my session has a name. So let's also dive into Twitter. Let's see what's trending right now. Let's see next to me, but let's Wednesday. It's not trending. Yeah, that's for all the millions following on the live stream. Oh, I forgot that. So that's configured now. Now I also need to hook up a handler, which is called matching tweet received, and that's under args. And I'll store that data in a queue. Those R's are of a specific type, which I don't know. This one. Let's include the namespace. Why isn't it doing it? So I also new that up. Now, whenever if you look into the event arguments, you see matching tracks. So if the tweet is received, every hashtag which matches my filter will be in the tracks, and there's the tweet, the specific tweet which was found. I won't count retweets though. That's our business logic. It's enqueue rx.tweet. No? Oh yeah, I just did the rx. And then we're gonna start matching any condition async. So I put this in limit. Where is the refactor thing? No. Whatever, I'll keep it in just in the method, because that's what we all do. Then there's the next tuple. Next tuple will be called by the Storm infrastructure, and it will tell my spout, now it's time to emit a new tuple into the topology, into the application we are creating. So here, I just need to check my queue. If there's more than one entry, we'll use that context class which I received in the constructor to emit the information. So I need to do a for each And first I need to get the item. Matched to q.bq. And for each track, and the matched to dot. So for each hashtag which has matched, we'll be emitting that information. So I could do just a new values, which just would outputting on a single stream. If you're outputting multiple streams, now I could say, oh yeah, I want to put this piece of information on that stream. I want this piece of information on that stream. So that's where the bolt could be outputting multiple pieces of information. That's the overload on the emit method, which takes stream ID. So for now, we're just going to again default stream ID, and we'll be outputting the new list object. This is part of the SSG, which you can see that I would change it a bit. That's a lot with dictionaries and strings and objects and type information you need to pass along. The team at Microsoft actually follows a lot the older Java libraries that they try to mimic with Java library, but so you can do in the .NET library. So what I did was I grabbed myself a book on Storm, which was a Java book, and I looked up, that's how it works, and then went to using IntelliSense. Oh, here's that method, here's this method. That's how you can find a lot of the information. So I want to output the hashtag, which is the track, and then I also want the matched to its ID. If we don't have any matches, we'll do with the normal keyboard, I can type faster. I promise. And then I'll just sleep for 50 milliseconds. That's just to free up some CPU cycles, because otherwise the next tuple method would just be continuously be hammered by the Storm infrastructure, and we wouldn't actually be doing a lot. Doing thread sleep though isn't that bad, because it's parallel by nature. So if I would deploy multiple instances of this spout, they're all running in their own process. So I'm not blocking all of them. I'm just blocking one single instance. Yes? Yeah, that's when I finally get to the topology where I wire everything together, I can use I could add some configuration metadata in it. And that configuration gets passed along to all the methods. Yeah. So we're almost ready with this one. So we have the constructor, the next tuple method. I also need one static method, which will be creating instances of this spout. So the Twitter spout, it's typically called get. It also gets a dictionary. So now I can just do a return new Twitter spout. Oh, it also gets the context. When I finally get around to wiring this up, you'll see everything click together. So this is all the work I had to do for to integrate with Twitter. So yeah, it's just a form of an unbounded stream of data. You'll see we'll get hammered a lot by the friendship hashtag probably, or that will be tweeting about SEBE, of course. It's not that hard. It's just a Poco class. Yeah, I actually spent more time writing the Twitter code than I did the Storm code. So we now have something which is emitting data. Let's now do some processing. So I'll add another class, and it will be a bolt. Do the hashtag hash. How do you write that? Hash, like this. Hashtag count bolt. So there's another interface to implement. Same namespace. Again, we'll add a constructor. We'll also implement the interface. It just has a single method, execute, and it receives a tuple. This one also receives the context. And again, here I need to declare what's the input of my bolt, what's the data it expects, and what might it be outputting. So again, we'll create a dictionary. Same thing, input schema. Initialize it. So what are we getting? A type, string, and another string. Passing all these dictionaries around does get quite cumbersome. So what would you do if you created more sprouts and bolts? Well, just wrap these in a class. So you can say, well, if I want to use the hashtag count bolt in my topology, then I just with a factory method or something, create output schema, create input schema, and then wire them together. So it's less error prone than using this approach. Just like with the other one, we need to wire everything together. Their component schema, new component schema. It has an input schema, but no output schema. I'm actually not sure if this is null safe, but we'll see that when we deploy it. So when we receive a tuple, we want to keep track of the amount of hashtag times the hashtag was tweeted. So I'll add another dictionary even, where we'll have the hashtag and then the count we had. Hashtag. I'm expecting a lot of traffic, hence the unsigned line. That's my shift lock. So let's read out the data. The tuple contains 2 strings. The first string is the hashtag, and the second string will be the tweet ID. You always need to work with this kind of a construction. Well, yeah, you actually have, but nothing prevents you from, instead of outputting raw data, in this case 2 strings, well, you can wrap it in a Poco class and use that as a tuple which you pass along to the other bolts. Then you do get object and then cast it to your Poco class, and then you also have the data. So what's important when you do that, you need to make sure that the Poco class which you're using as a tuple is serializable. You'll see later why it has to be serializable. So if my hashtag count contains key, actually has to be, if it doesn't contain, then I'm going to add it. Then I'm going to increment it. Not like this, of course. And then for further processing, I want to contact my website, which will be visualizing this data. And we're going to use Signal R for that. I've already included the package. So let's see what code. Well, I also need my app settings. Let's first add those. Oh, you could have told me. And then there's this piece of code. The bold. I need a hub connection, which I think is not an at-the-main setup, but actually something like this. Connection. And a proxy. And information. And I have Proxy. Okay, this is all ready to go. Then for the spout, I forgot I also need to pass in my credentials before the tweet starts. There. Another using. And we're using. Phew, that was a lot of work. Let's now get some coffee, or let's just continue. So we have the spout, we have the bolts. We now need to wire them together in a topology. Very good, Hans. I don't have any prizes though. I did contact Manning Books and hey, I'm going to talk about Storm. Can't I get a promotional copy? Because they had on Monday a Storm application book in promo, but I didn't reply. April. So inside my my class library here, because it's a class library, I could create several topologies, and you can mark each one you want to run with the attribute active, which tells the SDK, yeah, you need to execute this topology. And I need to implement another interface now, namely the topology builder. Oh. This one will be using the topology builder. And we need to give it a name. Every topology which you deploy into HDInsight needs to have a unique name. It can't be the same one, can't be used again. So let's call this the tweet demo. And then I need to add my spout. My spout also has a unique name. And here I need to add the factory method. I need to pass in a delegate to the creation function of my spout. So it's Twitter spout dot get. I haven't added it yet. Yes, I did. It's not static. If you wanted to use a dependency injection container, this is where you'll have to do service locator. You need to ask your IOC container, yeah, I want another instance. It's the only way to get it running. Here I need to define again the output schema, but now it's the dictionary has a signature. In this case, it's string and a list of strings. Dictionary. here we are describing more, instead of types, we'll be giving names to the fields the bolt will be outputting. So in this case, the first one will be, if I initialize my list, the first one will be a hashtag, and the second one will be the tweet ID. I won't, although I have to define it, I won't be using that information for now, but more on that later. And then there's the parallelism hint. It's a lot of L's in there. Here you can say how many instances of the spout you want to be running. For now, I'm just going to say 1, because that will be enough. And then the other argument which you can set true or false, but it's optional, is the enable ACK. Enable ACK, I would set it to true when I would be using a transactional topology. So when I want to make sure that my tuple, which is outputted, is has traversed the entire chain of bolts and successfully processed. But I don't need that for now. I guess we can, whenever a tweet would fail, I think we can live with that. So let's also add the bolt, Twitter bolt, whatever. Again, the delegate, bolt bit, which I haven't added yet. That's right. So another factory method. Again with the context and the dictionary of values which will be entered. Why is it params and not params? Because that's a keyword in C#, but in Java they use it as params, but I can't use it. So there you see the team at Microsoft which creates the SDK really tries to stick to the Java implementation. Here you can also see I'm now just newing up, but I could be inspecting the dictionary for values which I can use to configure my my bolt. And then a return type. Output schema, well, I'm not outputting anything, so I'm just newing up. Parallelism hint will just be the one. And then we can return the builder. Why is he complaining? That's not the right active attribute. That's the one. No. True. It's really active. So I'm just going to do a quick inspection. A new tab up. I have my list here, the contexts. Maybe we really should do VB then. Oh, another one. And error 3. Yeah, I don't program that much actually. So if this all works from the first get-go, I will be very pleased. Here I do, but here I don't. Yeah. That would be a dull application. So the hashtag which was received, the count. So that just is the indexer here again. And then the tweet ID. I already created a Storm cluster earlier, but I'll open the portal later. So when you install the SDK, you also get that option, submit to HDInsight, so you can do it all from within Visual Studio. But there are, of course, PowerShell commands if you're into that. Mike isn't here, so. So I'm submitting the topology. So you see it creates a zip package. And if I would go looking inside of the bin directory, which I will, you'll see also here you'll see the SCP host.exe, and that one will actually be the one who will be executing my topology. So all of that is packaged in a zip and then sent to HDInsight. Still doing. One thing to note, by the way, here I've just put my configuration in the app config. If you go on the documentation, there the team will say, don't use an app config, use an sp host.exe.config, because that's the one who actually executes the code, which was true late somewhere mid last year. But I noticed that if I just use the app config nowadays, that will just work as well. So the tweet demo is running, but there seems to be a problem because I don't see a line between those. Oh yeah, silly me. So I'm going to kill the topology. And let's fix this. I did set spout and set bolt, but I need to say to this bolt, well, you are listening to that spout. Or if you have multiple bolts, you need to tell to each bolt, well, you're listening to that one and that one. So here I have to do dot shuffle grouping and the component name, which is this name. And that's how I wire them together. More on the shuffle grouping later. So and you also see the inconsistency in the SDK with Java name here, shuffle grouping, so lowercase s. The HDInsight team is quite active on Twitter. Every time I was busy with it and I tweeted, oh, this doesn't work, that sucks, they always contacted me. So they are listening, I guess. Or perhaps I shouldn't say this, perhaps there are not many users. Oh, and it all crashes. Already exists on the cluster. That's with the naming. Whenever you kill a topology, it takes a while for the topology to kill, so let's just name it. Since builds are cheap, we're just sending this on again. So what you'll see in a bit will be the it will be running the topology, hopefully. And I'll give you a the link already. So in a bit, you'll be able to access that. You can already access the website, at tweetsweb.azurewebsite.net. I'll open it on my laptop as well. We are monitoring these hashtags and the friendship one. And whenever you'll be tweeting, we'll be keeping count. So there, yeah, I didn't kill this one. Here I see the Twitter spout. It's connected to the Twitter bot. There's one task running. You can see there are actually already executions. So if I go to the website, store the data in a database, so it's only when the tweets will be coming in that this will be updated. Oh, it's crash and burns, which is good for a demo purpose. So in this UI, I can see the entire log of my running spout instance. And if I just scroll about, I can see here that there is a no reference exception inside of that Twitter bolt. So something is null. Same thing I always forget. I did this, I think, 5 or 6 times, so I knew my talk, and I always made this mistake. But it's good, so now you could see the log. This log, well, I mean, it helps a bit. You can download the entire log of your running Storm application as well. There's when you use the Server Explorer, you can actually open HDInsight over here. This is my running cluster. When that opens, I can open the Hadoop service log if it wants. I'll just continue. If it would open, my cluster is outputting all of its data inside a table storage, and you can connect here and look into that log information, but it's actually useless, because when your application is running for a couple of minutes, there are thousands and thousands of records inside your table storage. And if you then try to use the query editor in Visual Studio or any other tool to look into table storage, you'll be busy for quite some time to find the entries. So I think you actually have to spin up another Hadoop cluster to analyze your logs and get the information. Did it die again, or is this the other one? It doesn't matter, because I have a prepared solution. Let's just use that. That's with demos, of course. This one is done. Yes, I trust my computer. So let's do it again. Publish. And this one will work. So I'm patiently awaiting the tweets. In the meanwhile, I can show you the cluster. Now, if you want to create a cluster, an HDInsight cluster, it's just in, I can do plus, search for or connect it here, HDInsight. You have to give it a name and select the type of cluster you want to deploy. So be careful, it takes 20 to 30 minutes to spin up a cluster. So the first time you'll automatically select Hadoop and we're trying to get your topology deployed, but of course that won't work. So select Storm if you want to use Storm in your application. The rest of the configuration is purely where does it need to store the data, what's the admin password, what's the remote desktop password, and then that's all you need to configure. So apparently, in the demo, I monitored something else. Yeah. So let's one last go. This afternoon, World Cancer Day was more popular than support sirens, by the way. You can already see it in action. Every time there was a tweet about the World Cancer Day, this one was updated. As soon as I killed it, it stopped. Submitting. Cue wait music. There we are. refresh. Oh, it's running. Somebody tweeted. So you see, we're constantly getting the tweets from Facebook, from Twitter, and the counts are updated, and every tweet which is received from Twitter moves to our small topology and gets added to our list as well. So I'll leave this running for now. And let's get back to some slides. And switch on the presenter mode. So just a little demo. So you see, it wasn't that hard, and there were not that many concepts to get going with Storm, but it gets more complicated, of course, when you create bigger solutions. So tomorrow when you arrive at work, you can automatically enter the Storm bingo and ask for a raise with your boss because you now know more buzzwords. But let's look more into the shuffle grouping, which I used to connect my bolt to my spout. But the shuffle grouping can be used between spouts, between bolts, and all of the components in Storm. And the shuffle grouping means that the tuple is sent to every instance of a bolt separately. So if in this case I have bolt A and bolt 2 instances of bolt B, each time a tuple is output from my first bolt, it will be sent to one instance, the next tuple will be sent to the other instance. So if I'm outputting 200 tuples in bolt A, 100 will be received by the one instance and 100 will be received by the other instance. So you get an even spread of the data. Global grouping is something different, where every tuple from my first bolt will be sent to the same instance of the other bolt. But then why would I increase the parallelism of this one? Well, perhaps I have other bolts as well, which does output to several instances. And there's all grouping, which is also interesting, where every tuple is copied actually to all the instances of the other bolt which is running inside of your topology. And then there's the field grouping. That one is the most interesting. That's why I had to specify those field names when I defined my topology. Oh yeah, that's the tweet and that's the hashtag, because the contents of my tuple will be inspected. So every tuple, in this case with field A, will be sent to the same bolt. If the field has another value, then those will be sent to the other bolt. So back to our Twitter topology, what would have been better, instead of using the single bolt which accumulates all of the hashtags, I could use field grouping on the hashtag and increase the parallelism. So I would have multiple bolts. Typically, it's just the same code which I wrote. They would all have a couple of hashtags in their dictionary. And then those dictionaries would have to be accumulated in another bolt, which could aggregate the results. Because now, if every tweet is outputted to the website, which actually creates quite a load, and that's how you can ease the load on your system. Here we see the field grouping in another example. So I have a bolt which says, oh yeah, the data which I output has these characteristics, and the store all the things bolt actually needs to receive the information per field. So here I need to use indexes to which align to that. Here you can see another incompleteness in the SDK. In all the Java SDKs, you can use those strings which you use over here to name them. You can use them over there, but in the .NET SDK you need to use integers to reference them. So instead, the hub ID means 0 and sensor ID means 1 in this case. So here I have, let's say I have 16 event hub partitions. That means I have 16 bolts of store all the things running in my topology. And all of the data which is outputted by this bolt will be grouped by hub ID and sensor ID, and each bolt will receive part of the information. But all of the information of the same hub and the same sensor will be in one bolt. That's something you can be sure of. So we talked a lot about programming with Storm. What does it look like? How does my typical cluster look like? When you create the cluster in HDInsight, this is the hardware you're going to get. 2 Nimbus nodes, 3 Zookeeper nodes, and 4 supervisors. Zookeeper is a technology which is used in solutions in the Hadoop ecosystem. Like HBase also uses Zookeeper, and that's just the container of the configuration data. It's not used a lot in Storm. It's just configuration and to keep an eye on the Nimbus servers. There are 2 Nimbus servers, an active one and a passive one. Yeah, the passive one takes over if this one goes down, and they orchestrate the entire thing. They are saying, oh, this tuple needs to go there, this bolt needs to be activated over there. So there's a lot of communication between the Nimbus nodes and the supervisors. Your spouts and your bolts, they are running on the supervisors. They are doing the actual data crunching. So that's a lot of hardware. You see what that means. Those are the typical pricing tiers which they belong to. What does this mean? 1 hour costs €2.60, which means running this for a month costs €1,800. I'm not saying it's cheap to keep running for a very small solution, but if you want to experiment with it, yeah, you can. If you have Azure credits, then you can take that hit. You can, when you create a cluster, you can say, oh yeah, I just want 1 supervisor, and then the price goes down to about €1.60. But Nimbus and Zookeeper nodes cannot be changed. When you scale up or down your cluster, it's just supervisors that gets added or detracted. The Zookeeper and Nimbus nodes stay the same. Any questions so far? Okay. Let's look at 2 scenarios. Who knows this website? A lot of you don't. Go check it out and check if your email is contained in any data leak. Troy Hunt, the creator of the website, also check out his blog. It has a lot of good information. Once had the idea of let's take this data dump and make it so that anyone can access it and look up his email address. He has been blogging regularly about how he created the solution and the improvements he made on it. And in the blog comments, someone once mentioned, I wonder if HDInsight and Storm or Hadoop would be a viable alternative to the solution he created. He created a solution with web jobs and message queues to get the data going. So I took it upon myself to create an alternative solution with Storm. So the first thing I had to do was create a dump of 100 million unique email addresses, because I couldn't find the Adobe lead, apparently. So I uploaded that file into blob storage, which for me in Belgium was very easy to do. If you go read Troy Hunt's blog, he lives in Australia, by the way. It's more difficult in Australia to upload a massive gigabyte file over his network. Then I created a cloud service. This cloud service, I scaled it up to, I think there are 20 clouds, 20 instances. And what did the cloud services do? Well, they went to storage queue, and in storage queue were 100 messages, and each message contained an index from and until of the rows in my file in blob storage. So the cloud service would spin up, it would get a message from the message queue, say, oh, I need to read the file from row 1 million to 2 million. And all the other ones were processing them as well. And all of that data was pushed inside the event hub. So it took me about, it took Azure about 2 hours to get all of those 100 million email addresses in the event hub. I didn't have to scale anything in the event hub. It just could take all of the data without any problem. The cost for this was €5. And then the cost was mainly in the cloud services, which were running for 2 hours. So I then created a topology. I used the event hub spout, You don't have to write a spout for event hubs yourself. Microsoft has already done that for you. So the event hub spout would be consuming the event hub. Best practice is to increase the parallelism to the partitions in your event hub. So if you have 16 partitions in your event hub, then also deploy 16 event hub spouts. Those event hub spouts would be outputting with shuffle grouping to my table storage bolt. The table storage bolt did a simple lookup in table storage. Do I have this entry? Yeah. Then I'll update the data leak count in which this one was contained. If it wasn't in table storage, I would add it, obviously. The output of my table storage bolt was only the new email addresses. And those new email addresses were sent to SQL Azure Bolt. The SQL Azure Bolt outputs its data in SQL Azure, but I didn't do normal inserts. No, I batched it. So when there were 100,000, when there were 1,000 email accounts inside of the SQL Azure Bolt, I would do a batch insert into SQL Azure. Or when 30 seconds had passed and there were not 1,000 records in my SQL Azure Bolt, I would do the same processing as well. From the moment you add the event hub spout from Microsoft, well, you also, and you want to use the, event hub spout, you have to do something like this, or at least I had to do it like that in May of last year. This shows that you can mix and match Java and .NET spouts and bolts. So if you already, which you guys didn't, if you already had a topology written in Java, that you could reuse components, or if you find interesting stuff on Git or whatever, you could use that code and plug them inside of your topology with something called Java component constructor, blah, blah, blah. When you when you create a hybrid topology, there's Java and there's .NET. And since we're outputting tuples, and the tuple contains the entry from the event hub, so when you do something like this, you also need to say to the first bolt, which listens to the event spout, how it can deserialize the data. Microsoft has already written a deserializer, so it uses a JSON format between the Java components and the .NET components. So what was the performance of this? With just the typical hardware, I had 16 spouts, because I had 16 event hub partitions. I had 256 table storage bolts and 2 SQL bolts on an S3 instance SQL database, whatever that was at that time. What I noticed, I could process 10 million email accounts per hour. That's nice, but that's not really the scale I wanted. I want more power. So after analyzing, and this was the best result I got with the topology which I created. The main bottleneck was table storage. I was doing, the table storage was designed with the partitions being the domain name and the row key being the email address. But I had created 100 million unique email addresses. So there were 100 million different partitions with each one row being the one row. So I created a new test set which mimicked the data that was contained in the Adobe. Yes, I had a lot of time. So which mimicked the data in the Adobe page, which was around 70% of the addresses were of like 26 domain names. So so the partitions would be could be reused. So I made that change. So now I have this topology. The event hub spout is still the same. It's using shuffle grouping to the lookup storage bolt. So the initial bolt was split into 2 different ones. The first one would be checking, does this entry exist? If it doesn't exist, it would also know that, and it would be outputting that data to the other one. So I will be receiving, so this bolt would be receiving grouped by the domain name, all the accounts, and it knew if it had to do an insert or update. And table storage also enables you to batch 100 commands. So I could update one partition with 100 entries at a time. So I thought, yeah, this will probably be better. I have a more realistic data set, and it's more optimized to use the table storage. I skipped SQL build because that one was just, it always worked. It was more and fast to keep up with the previous example. So after running that for 2 hours, yeah, this is the sample topology. I was able to process 28 million records, which means 14 to 15 million actually per hour with this change. It's whenever you develop a topology, and this is the kind of loop you'll go through. You will see, you'll create a topology, yeah, and think, yeah, this is the one that's right. Test it out in production or on your test environment and say, oh, there's a bottleneck here, there's a bottleneck there, and you need to make changes. Sometimes it means splitting up a bolt into several different bolts, so you can play with the parallelism. Sometimes it means combining bolts together, because there's also always a delay by transmitting the data from one bolt to the other. I did run into another bottleneck, by the way, because you can see the error count actually over here. And I couldn't explain what's going wrong. I went inside of the log and I couldn't really find it. So I asked on Twitter, and immediately someone from the HDInsight team said, oh, let's take a look at your application. And he said, yeah, it's probably something with another component which you're using. It was actually the event hub. I was now I would say pulling more information out of the event hub than the default configuration allowed. So I scaled up the event hub. Here you can see, here are the error rates is going up. So here I'm still trying to figure it out. Then I scaled up the throughput units of my event hub, and then all of a sudden I'm able to pull out more than 1 million messages out of my event hub. So whenever you're tuning your topology, you'll notice restrictions on the other systems you're using. So you'll have to continuously improve and adapt your solution so it fits and it doesn't bring down other systems. Who was at CloudBrew? Who was at my session about the tic-tac? So tic-tac is a proof of concept which I'm doing with some colleagues for a home monitoring system for every utility meter you actually have in your home. It's a we had set some goals. Yeah, it had to be cheap. It shouldn't require any new hardware inside of your gas meter or your electricity meter or your water meter. They should just be able to be monitored. We figured a way to do that. It eventually boils down to a bunch of Arduinos. So next to my water meter and my gas meter and my electricity meter, I have an Arduino. It's picking up the consumption and outputting all of that data to a Raspberry Pi, in this case. And the Raspberry Pi is then transmitting this to Event Hub. At the time of CloudBrew, we were using WebJobs to pull that data out of the Event Hub. And I've now been busy with HDInsight and Storm on looking for a topology to process that information as well. This is the best slide with all the turning wheels. So we still have the Event Hub spout. And then the next bolt which I'm using is a transformation bolt. And what does it do? Well, it just transforms that JSON object which I received from the Event Hub to a .NET object. So I don't have to do get string and get this and get that. No, I just can use the object as is. The transformation bolt then outputs to two different streams. One stream will be used by table storage, which would be storing all of the information. So we can use so I could use Hadoop to do some analysis on it. Or if there's a failure or I made a bug somewhere in the topology, I could later rerun all of the readings again through the system. So fix any errors we had. Then there's on the other part is the enrich bolt. What does it do? Well, at this point, I just have strings and integers. So like sensor ID, hub ID, and a tick or a date, date of the measurement. And the enrich bolt does some enriching. It looks up the user, looks up the sensor, so it knows, oh, it's actually a water meter, and that means that if there's a reading at that time, that half a liter has been consumed. That's what the enrich bolt do. So there's more information inside of the tuple. Split again. There's the unexpected use bolt, because we're tracking all of we're gathering all of that information about your typical usage, which means that after a while we'll be able to make predictions. I typically come home at 6 or 7 in the evening. Well, if my heating system turns on at 3 p.m., I know there's something wrong. Or well, it shouldn't be turning on. So the unexpected use bolt is actually going to machine learning to make a prediction. So let's see if is it normal that there's a readout at this hour. So that's what that part does. If it isn't correct, yeah, we'll use another bolt which will send me an alert, so I get notified that there's consumption, water or electricity or gas at an incorrect hour. The other part is again accumulating. So I'm batching all of the readings of the last minute inside another tuple. And this one will be outputting every minute. Oh yeah, last minute, 5 liters of water has been consumed. That's what he's outputting. And this one again is accumulating and saying, oh, the past 5 minutes, I've used 100 liters of water. That's not correctly. And then again, I will get an alert to say, oh yeah, you probably have an issue somewhere. So that's the sensor topology which we are creating. A few slides back, you saw the create JavaScript closure, blah, blah, blah. Nowadays, you have an easy method, set event hub spout, which the SDK team has created. So no more closure parsing. You can just use this to configure it, and it will be listening to your event hub. How can you do something like that accumulation or use the system? Well, the usage past 5 minutes bolt, I dropped some code. It receives tuples every minute or so. So in the L stack, we're storing that in memory, or I could be outputting to a database or whatever. And then every 5 minutes, because the bolt is set up like that, it receives another tuple, this time not a readout, but a tick from the tick stream. And the tick stream gets active when you say this bolt needs to be alerted every second, every 2 seconds, every 5 minutes, whatever you want. So it receives 2 kinds of tuples. So when this one fires, I know that 5 minutes has passed. So I can look again to the data which is stored in memory, see how much has been consumed. Oh, it's more than a certain threshold, then I can alert the user as well. And with all that, I'm finally through my examples. These are my contact details. I'll be here, or you can just tweet me or send me an email if you have any questions about this. I haven't used it in production or with a customer. It's just my free time or the time I got from my employer to look into this. So I can't share any battle stories like Martin did Tuesday at Physics. Oh yeah, you can also RDP to your cluster, by the way. That's something you'll like. So thanks for listening, and I hope you learned something. And next time you're running into a new application, perhaps Storm will be a good fit for your application. Thanks.